Are you developing more? I mean,
Yeah.
I went through some of the stuff that you had that's in the Dropbox. I watched the 3 videos and opened up all of the labs.
Yeah. So obviously what has to happen is, so for instance, like Maryland just upgraded some things, and I'm looking at going away from the 850 PLC Allen Bradley, but I'm working on my interface from my switch panel to tie to that 850 PLC. So I have to redo everything as far as the wiring side. And when I do the P1000 Automation Direct PLC, I got to do the same thing. I got to call out the different I/O and those kinds of things. So we'll have probably by February, I'll have all that PLC stuff done, and it'll match up to my new trainer. That water trainer back there, that's all acrylic and some 3D printed tanks, but I've got some new ideas for that.
Is that version 2 of that tank as well?
That is actually version one. That was one of my prototypes. It's even
Okay.
got right here, it's got a safety box up there, that gray, where we can actually introduce 120 volts to that heating element. And it's got some redundant safety built into it. So the kids can't leave leave a heater on overnight or something. So it's got some little couple levels of things have to be satisfied before that heating element will turn on. So there's a number of things that I want to do with that trainer, but it'll look somewhat like that, but it'll be another form factor of the extrusion. It won't be this heavy aluminum or a stainless steel thing with the big legs. It'll look more like the legs that I have. I have to use those same legs. So when I did that one, the big aluminum or the big stainless steel one, like you probably have, we had to get those big legs, and it makes everything just massively heavy. So anyway,
It's a heavy one, and I can speak to the costs of sending it from Oklahoma to or
yeah.
Nebraska to here.
Yeah, and the nice thing is this new one is going to break down easier, so you can box it up and break it down, and just like the one that you're using in front of you that we're going to talk about today. It comes apart, it goes back together easily. You can have sub-assemblies. I just like it so much more. So
You
anyway,
know,
well, I'm going to shift over to my other screen, so you're going to see me disappear for a second, and uh, just bear with me here for a moment. So. I'll leave it like that. So on this particular trainer, what I just sent you guys was, and I'm sorry for my micro clips here, but I don't have the same motor that you guys have. So what I did was I sent you the wiring diagram, which we'll go over here in a minute, because this adds a really nice element to things that you can do, and how I've got it wired up and this is the wiring that you have on the document that I shared in the Dropbox. So I've got a magnet switch here, a Hall effect switch, right? And I'm running it through our manual control. And as I speed that up, because it's a variable gear motor, I'm running it through a relay here because I really don't want to drive this load here with this sensor. Now, obviously, you guys know enough when you're teaching classes that you just don't hook a sensitive sensor up to a heavy load, right? So we use this relay as an isolation device. You've got this same relay, and you've also got the cube relay. So all these things you have in your kit, and you can wire this up per the document that I included in the Dropbox. So you get all the wiring just like this. So that's one element. And when you get to the PLC side, just imagine what you can do with counters and dividers and those kinds of things. So right now I just have one of the lights turning on, and there's an analog piece that will be able to drive a 0 to 10 to this motor, because I've in the new PLC kits I've got a controller that will be able to go 0 to 10 from an analog card, and we'll be able to drive that motor, speed it up, slow it down, and do some different things with proportional valves, like up here on that water trainer. So this is one element of what we're doing. The three experiments that we talked about were the force sensor, the reed switch, and the light diode, or excuse me, the light dependent resistor. And I've got a number of those things hooked up. And what I did for just to save time so we could do questions is I've saved everything on my breadboard. So for instance, I've got the light sensor right here. Okay. And in the experiment, I ask you to have the students, I'm going to set I got the same meter here that you have. Okay. I'll set it up here. I'm going to set the mode to auto. And when I look at my meter in this, what I would call ambient light, right? I see 15 K ohms of resistance. When I cover it, I see it jump up to 15 meg. Okay. I know you can't see my screen, but trust me, that's what I'm reading.
We can see your meter screen.
Okay, good. So then I have you hold it up to a flashlight, and then we see it drop down to 2K or 3K or something like that. So that's kind of the experiment. And once you do that, then you can insert it back into a circuit and you can do something on the breadboard. So not going to spend a lot of time with that, but there's a lab out there that I touched up, and it's in the Dropbox right now. And it talks about how you can put that into a circuit for your students. The other one is the force sensor. And all these kind of work the same way. So I'm not distorting them. I'm pretty close to this microphone. Can you hear me okay?
Yes.
Okay. So now what I have is I have this force sensor, and when I just barely touch it, I get 4 K ohms, 2.3 K ohms. When I really squeeze it, I get down to about 530 ohms. And when I let it go, I'm up in the meg. So it's overloaded. So we can say it's approaching an open. So when I have it in the circuit, it's really not doing anything. So I'm going to pull it out where my leads are, and I'm going to put it, see if I can find my spot here. I'm going to put it in the circuit. And you can see when I squeeze it, I turn that light on. And if I squeeze very lightly, it gets very dim. If I squeeze very hard, of course, the resistance drops down. So if the resistance drops down, what happens to the current? Ohm's law, it goes up. So that's the experiment we can do here. Now, I also in the paperwork in the labs, I also include, because I'm always doing this, I included what's called a current limiting resistor, because you never know if you short something out directly. It just so happens the lights that I gave you guys, these LED lights, have built-in resistance, current limiting resistors in them. But you got to get those kids to understand that if they put an LED in, just a straight LED, it can maybe only draw 30 milliamps of current. So you got to be very careful to have a current limiting resistor in series with it. So, and again, that's covered in the labs. The third one was the reed switch with the magnet. And so when I pull the magnet away, and if you notice, I'm just going to do this real quick. I have a current limiting resistor of 4.7K. I'm going to take a shorting wire and I'm going to touch the resistor on the other side and short out the resistor, and you can see what happens. And that's a good demonstration to show the kids. Oops, sorry, my camera's looking at something it's not supposed to look at. You can kind of show that to the kids that when I short out that current limiting resistor, what exactly happens. And that's what happens when I do that. I'll put the magnet back on my reed switch, and then I short it out, and you can see what kind of happens there. So remove the magnet and it turns off. The other thing that I had in here, and I confirmed it, I have two 2.2K resistors in series. I measured the current with our meter. And I first have the kids do a calculation of that. And it just happens to turn out, I'm just going to go ahead and do it here because we've got time. So I'm going to take these resistors off of here, or these leads. And these little leads, you should have them, these little breadboard leads. So when I look at the total resistance in the circuit, and there's no power applied to it, so I can take a reading over the top of it and see what the resistance is. And I have 4.37 k ohms of resistance, 2.2 resistors. So that's pretty close. So if you do Ohm's law, and I'm running all these experiments now, and this is another improvement, Todd, over the other trainer, is we have a 12 volt DC to DC converter. So we can run these breadboard labs on 12 volts. Plus we have kind of mixed signals. So for instance, this particular relay does work off of, it's got a 24 volt coil. Likewise, this one. But this motor is, which you can't see, the motor that's tied to the gear, it's a 12 volt motor. And the reason I picked the 12 volt motor as opposed to a 24 volt motor that you might see on an industry a machine is because I want to be able to do a 0 to 10 volt control out of a PLC. So that's why I picked that. So we have to be careful when these kids are reading the labs, they have to understand. And I put in there, please take note that this is a 12 volt system and this is a 24 volt system. So I make that very clear just how you're jumping around. So both of these obviously are 24, but this load happens to be 12. So when we're driving into that, I have 12 volts coming into my controller motor here, right over here. I have 12 volts going to there, which feeds the motor over there. But the control system is all 24 volts coming into that. Okay. So
Okay.
back to our reading our current, or the milliamps that's coming out of here. I'm going to put the meter in series. I'm going to make sure I get the polarity correct just so it reads correctly. And I'm just hooked up to 12 volts on the high bus side, and I'm going to hook up to the low bus side. I'll set my meter first to milliamps because we don't want to be going through the circuit because the power is on now. Let me just make sure that the power is on. Oh, I'm on AC. So with your meters, make sure that you move it from AC to DC. There's a mode switch right here. And because it's auto ranging and such, I had it on AC. So it says that there's 2.72 milliamps. And if I were to take 12 volts divided by 4.2 k ohms, I get 2.72 milliamps, 2.73 milliamps. So it proves out. So in all of our experiments in the IMEX system, we always have the kids do a calculation first, then they go back in and they test it with a meter. So we can confirm that we really did it. And why do we do that? My main reasoning is if I'm picking something like this relay and I'm in industry and I just take it out of inventory and I just say, well, I'm just going to put it in the circuit. Well, what kind of load am I driving with this? Can those contacts handle that? Or better yet, what output from my PLC is driving into that coil? And am I going to burn an output up? And again, I know I'm kind of preaching to the choir here, but those are things that these kids kind of have to understand when they're selecting components. And that's why we have them read data sheets that I usually include for all the items that are here. And we, before they start applying power. So that's an example of, taking a voltage divider, which again, if I were to read right off of here with my meter, I would see 6 volts, right? And let's just confirm that. I'm going to disconnect my meter so I don't range through while I'm going back to voltage. I'll set my mode to DC. I'll turn the light on. And because I was reading current before, I'm going to go ahead and put this back in. And now I'm going to read across a resistor in the voltage side. And we suspect we should see, if I put the range correct. Hang on a second. Helps if you get the wire in the right place. So, okay, so I've got 11.94 volts, right? And if I move my meter up to the voltage divider across here, we should see something close to 6 volts or 5.98. So the voltage divider. So that's another way I could run that into the motor if I wanted. And you could have your students make multiple voltage dividers, and then you could switch in with these switches over here, right? Even without a PLC, you could push individual buttons and you could have them call up a certain voltage divider and have the motor over here speed up or slow down. There's all kinds of different things you can do with this trainer. So I'm going to pull away from this so we can go back to the other, and I'll come back to this other. I'm going to share my screen real quick here. And let me turn this off.
So Doug, I do have one quick question. The 5 labs that I see there,
Yeah.
You said you've got the reed switch with the magnet, the force sensor, and the light.
The force sensor, the reed switch, the force sensor, and
you were lighting the LED.
yeah.
Do you have a wiring diagram for that?
It should be, let me go get it.
Because I don't see it in the labs.
Okay, let me pull up
I
the
see a lab
LDR.
for force sensor, reed switch. Then there's a series circuit lab 5, and the one I'm looking at with the only one that's the relay PT2 lab has a circuit of sorts in there. I see where we're going from the 12-volt power source to the green push button switch over to the relay coil.
Yeah, let me check. Can you see that?
I do now.
Yeah, so this is the light dependent resistor. So this is like the first one, and I notice I have a typo here. That should be 12 volts. I'll fix that and put it back in there. But here's the other one that I was talking about. So here is the bus, right? The 12 volt, 24 volt bus that's going to turn on the relay. And I put a picture of what relay you should hook up. And then the contact, which happens to be CR1-1 from CR, right? The contact there.
Well,
That's hooked
that
up.
lab, Doug, that lab is not in the Dropbox.
Oh, it's not. Okay. I thought I just put it there.
Let me cycle the Dropbox and see what's going on there.
And of course, oh yeah, there's the Dropbox. Manual motor control, sprocket assembly, LDR.
All right, so now I see 3 new things that were not there before.
Yeah, yeah. So with that said, just because I want everybody else to be able to see these, I will fix that, make that 12 volts, but I include schematics with everything. So that should be sufficient for the students to hook them up. The other thing that I want to kind of discuss here, and I want this kind of on the record for everybody that's going to maybe watch this, when you're using this trainer, let me get a picture of it because it's kind of important. The other trainer, we were very hand holding and I really didn't like it. everything was dependent upon somebody else doing the wiring. So what I want to show you here, let me just go to my albums. And I actually have a picture of, it could be yours, Todd. Let's see if I put it in my albums here.
All right, now I'm seeing wiring diagrams and
Yeah. Yeah, it's just in the photo. So I'm going to call up our Florida. Well, I'll just do it here. I'll just do it here. This will work. This will give you the idea of what's going on. So I'll share my screen here and show you kind of what I mean. Okay. So you see that.
yep.
Oops. I'll just pop this one up. So what I want to make kind of clear to people is the only wiring direction that I give in the wiring diagrams that you've got that's already in the Dropbox, and I've kind of improved those a little bit, is this section right here, which I call the bus, the 12 volt, the common, and the 5 volt right here. And then tucked away inside here is the circuit breaker that we use as an on-off switch. And then there's one more switch in there, or excuse me, one more, it's my mom's Christmas card. There's one more terminal block right in here where we bring the common in from the outside 24 volts. So all this here, I really want, other than this is very dedicated because the wiring coming out of here is very dedicated. And we call those out. And you guys remember doing that. And we made some improvements to this. I'm going to be talking to Marilyn about an update kit down the road. But other than this here and this up here, I want the instructors to kind of use their imagination, let the kids wire how they wish here. This is the only side that I'm very particular about when we say wire it like this. So when you turn the switch on, the bus becomes hot. You can obviously run a yellow or an orange and black wire to here in the wiring management and have your terminal blocks down here at 24 volts. And you can even put a red one down here for the 12 volts, which would make an easier jump just to get right over to here, right? So I want that imagination. I want people to kind of do their own drawings. On the other trainer, every terminal block was called out and every terminal block had a job. The idea behind this particular trainer is it comes apart very easily. You can tear this thing down very quickly, take the thumb screw or take the screws out, everything is thumb screws, and somebody else can use this back plane and this platform, but you may choose to keep this wired in, right? Just like you may choose to keep this wired in, you unplug the cable, take the two thumb screws out, and this whole thing lifts off. And then somebody else can come along and do their own wiring. So I just want to make that kind of clear that I'm not going to get real precise with calling this terminal, 16A and terminal 16B and terminal 17A and terminal 17B, unless I get some feedback from you guys saying, hey, it's hard enough, put 3 of each in outputs and inputs. I usually call the blue are the inputs and the gray are the outputs, or vice versa. I'll call that out. And I can number those that people want. And the reason I went with double stacked ones here is because it saves a lot of real estate. If you notice the other trainer, there's 30 of those things stretched across there, and it takes up a lot of space. Well, I can get 2 for 1 in every one of these slots. So that's why we're doing what we're doing with the double terminal block header. So Todd, any questions about that, or any comments or concerns about leaving that up to the teacher or the student, or do you think that should be called out and very solid, set in stone?
Well, having worked with the other trainer and it all being called out, I mean, well, you know how it starts. They start us by going through building it and connecting it up and checking to make sure everything's that way. And then we go through the labs where we build, we make something work, and you know which one to plug into. What I liked about what we've got here is there is a prescribed way for some of it, but more to the point with the blue and gray, it is a little bit open ended so that I
Yeah,
can get them to focus more on the circuit itself. Like you need to go from 12 volts to this and back to this and, have that kind of control. So for me, those blue things and the gray things are going to connect to one of the buttons or one of the lights. And,
right,
end result is that they've got to be thinking through the process. And if I tell them just, wire X to Z and then Y to A, they aren't thinking about the circuit, they're following directions.
right,
And while it's tough enough for them to follow directions, I ultimately they're going to learn more and deeper if their first thought is, what circuit am I making? And
yeah,
I don't think you get that with the first trainers I've got.
no,
This trainer, I think you get an opportunity to get them to focus on what is it I'm trying to do and how do I get there from here.
right. And here's kind of case in point. Notice the motor controller. I just happen to put it in a black box, which I don't like anymore because it's hard to get to the wiring. But it's in a different place. The breadboard's down here because somebody might say, well, geez, when Doug was working in his video, he was reaching across everything. I want the breadboard down here. And
Mm-hmm.
I'll bring my power around and I'll come in this way. So that's why we do it this way, because it just opens up a whole bunch of new avenues. Plus, I got these other little things that I chose to go. If you're wondering why you don't have this, I have an adapter plate that can lay the motor sideways or upright, depending if you have a Geneva Convention, a Geneva movement, or that sprocket. I chose the sprocket with the magnet switch because I felt that it opens up more opportunities for kids to see something moving and they can make a light blink at a different speed. And especially when you get a PLC, we're going to do all kinds of stuff with that sprocket and that magnet switch. But there's also, when you buy the sensor kit, you'll have a capacitive sensor that hooks up out there, an inductive sensor, a through beam sensor that, like I said, is going to shoot all the way around the unit through the sprocket gear teeth. So those are all things that you can add or take off as you wish.
Yeah. No, I like that. I also like, there could be a way to challenge them with certain projects that, they'd have to design an adapter that goes on the board and then wire up something to it. And so there's a lot of opportunity for that.
I agree. And so I didn't want anybody to think, well, he got lazy and he went away from that original. And I'm very, very pro kids have to learn how to use hand tools. And one of the things that came up when we went from iMech 2 to iMech 3, which we're in right now, is one of the reviewers who was looking at the trainer said, where's the mechanical aptitude? This thing comes pre-bent, everything's on it, it's all wired, and it goes out. What are the kids doing? So I made it a point to go back to this extrusion where they have to use hand tools to put the bar stuff together, read instructions where the rubber feet go. And so those are the things that, I think are important. And as well as they're very well documented, I think the kids won't get frustrated and they'll be able to put things together. What you guys didn't see is a series of 5 videos that I can post out there that explain every step of building the trainer from the frame portion. And so when if I share my screen again, if I just kind of trigger through this, you'll see all kinds of things where I'm just trying all these experiments and like how things go together, how the legs go on, and there's videos that explain all this, and I take it just step by step by step, and like here's all the pieces that make up the outer frame of this, and then how you drill the holes. But we drill and tap these holes for you now, where the feet go, how the legs go on, where these get the T nuts, how they go in. So all that is kind of been explained. So if you have somebody that says, hey, I want to take this trainer apart and I want to rebuild it, you'll have the videos. Plus each video has like there's 5 different sections about how to build it. So you can watch the videos and you can look at the documents. So the only reason I didn't include it all for our Florida visit is because there is so much stuff, But now that you guys have it, I'm cleaning it up because Marilyn kind of saw where I had some rev numbers, like certain lab, Rev 4A. And she's like, well, what does that mean? Well, it means a lot to me because I jump from A to B, or I make a major rev change from 3 to 4. So I'm going to go through, clean those up, and put them all in modules. So you'll have everything on the electricity side that goes from building the unit to resistance to series circuits to parallel circuits, and you guys will get all that together. But if you can't build it, that's kind of a frustrating thing. So
now you talked about kits, additional kits. Have we figured out how we would be purchasing that from you now?
well, Marilyn was our first person to purchase a PLC kit, and the kit really includes any brackets that we need. Now, what I did for you guys, and I'm gonna kind of change the pricing in our as we go forward. I like the fact that the electricity trainer that you have includes the motor and that sprocket wheel. I like that, but that really was going to be a part of the sensor kit because you're making something move. And that wheel, if you look at that, there's some really bizarre holes on it. One is for an inductive sensor, one's for a magnet Hall effect, one's for a capacitive. So there's all these sensors that bracket up on that thing. So we, on our website, if you go to the QR code, don't talk to Marilyn about this because there was some little hiccups on it, but you'll see a sensor kit and you'll see a PLC kit, and then you'll see the base trainer itself. And the base trainer is what you have. Now, can you go out and buy your own PLC? You certainly could. But what you don't get with it is some of the step-by-step curriculum that I'm going to be designing and developing like we have for the other
And where did you say this was available?
What's that?
You said a QR code. What website am I going to?
Well, if you go to the school website,
South Central College.
South Central College. Let me go to my share screen here.
Todd,
Yeah.
I just bought you a PLC add-on, whatever kit.
Oh, great.
It's going to be sent to Maury at the college. I'm just not sure about the timing, if it's going to be sent. Doug, you need to listen to this. I don't know if we can send it there when the college is closed over the holidays. I don't know what.
No.
No, that's what I was thinking. I think
we have a problem with like Amazon leaving stuff.
Yeah.
They know we close at 2:30, 3 o'clock, and they leave stuff on our doorstep. And
Oh, yeah.
thank God we haven't had anything go missing yet.
Yeah.
So Marilyn,
Yeah.
Is this an issue that you have to take possession before the end of the year, or
No, we just have to pay the bill.
Okay, then let me hold everything. I mean,
Yeah.
things got a short lead time. It's
Yeah.
not like I have to get these brackets made in Nebraska.
Yeah.
And then I'll just ship it where we know somebody's going to be at the door
Yeah.
picking it
I'll
up.
have to check. Maury said he was going to try to be on this call, but he obviously didn't make it. And I just need to check with him when the school is going to be open again, after the holidays, because the colleges are out. The high schools are still in session, but most of the colleges are gone.
Yeah. Okay.
Well,
Well,
that's fine with me.
yeah.
I'm no hurry to get these kits or the PLC,
Yeah.
but I am taking your trainer home, Doug, so I can work on it while I'm up in Athens, Georgia for a while.
Yeah.
Plus,
Well,
my
now,
dad's an old engineer and he's curious, and I've been
yeah.
talking it up, so he wants to play with it too. So,
Well, now you can make that motor spin and you can shoot. I mean, you can do it. I mean, if you have inductive sensors with a 12 millimeter barrel, you can do all kinds of stuff with it. I mean, that's the beauty of this one is your imagination. It's I hate to say it like this, but it's like buying you an Etch-a-Sketch and me putting the drawing on there and saying, okay, now
right.
don't shake it, just so I like, and I really wanted to have a little bit more thorough discussion about this in front of the group when we were in Florida, because I really wanted some good feedback, whether it was critical or whether it was positive,
Hmm.
because it's not too late for me to go back and change a lot of stuff. Like every terminal block has a name, every wire goes a certain direction. But I really believe that the kids, and what I've seen with this trainer back here, is some of the kids that get that water trainer, they color outside the lines. They do things that we didn't envision. They'll ignore a tank, or they'll bypass a tank, or they'll do something else. It's like, well, if we had this stringent way of doing it, the instructor might say, hey, you're not following instructions. Well, I know, I made it better. I did something that the guy who created it didn't think of. And it's like, well, perfect. That's good. So here's our site. And if you go to academics and go to programs, and then go down to Mechatronics, like they've changed, this.
It's under
Mechatronics.
manufacturing.
Yeah, manufacturing. And then if I go down to iMech right here, it's kind of hidden, but the QR code takes you right to it. And then you can come in here where it says buy a trainer right here, iReal page. And then it takes you to, oh, well, that's not.
Doesn't take you anywhere.
Are you seeing that too?
Yep.
Oh, you know what Cindy
The link's
did?
broke.
Because Marilyn was having trouble, she shut it down so she could fix any of those hiccups. That's what happened, Todd and Marilyn. So I will get with Cindy. Yeah, Marilyn was having trouble with the base trainers. We run it through our Center for Business and Industry, and they're used to having students sign up for like OSHA 30 and ask all these questions. So we're breaking into the selling hardware. So we thought we had it fixed, but just this last thing, when I said Marilyn's going to do something else outside the system, I think she just shut it down to try to get it fixed. So,
All right. No worries. Something new for the first of the year.
yeah. Well,
I
but
do have another question. You have a lot of components in this. Do you have a supply list or a component list because like you were talking about the relay and you were talking about the specs for it.
yeah.
One of the things I'd like to teach my students is here is the relay we need, go find the specs. And if I know what relay we got, I can have them search the internet for the specification sheet.
Yeah. There is so here's how we did this. And this is good for the others to hear this on a recording. And this is really what I wanted to talk about today. I didn't want to really give lectures on voltage drops and those kinds of things. I wanted to talk about this trainer and how it can be used. So when you purchase that trainer, let's say you're a school like you, and you have all the hand tools and you have all the components and resistor drawers and capacitors and all the sensors. You don't want to buy that. So what we did was we broke it out where you buy the base trainer like this one, like what you have, and that's called the electricity or the iReal trainer. And then from there, you could buy a component kit with Resistor, all that cool book of resistors that you guys bought, that you got, and all that came from Maryland. The light sensitive, relays and resistors and all that came from this kit that has all these parts in it. There's also a tool kit that has, the ferro crimpers and the 3 millimeter screwdriver. And now I understand we need a 1.5 millimeter screwdriver because it won't go into the little breakaway DIN rail, DIN cable uh, connector that when we were down there. So we had to borrow some jeweler screwdrivers. So all those things are on that site, just like the PLC kit and just like the sensor kit. Somebody could look at this and go, now I will tell you that it would be tough to make your own brackets. I know people can do it, but it would take a lot of time and those kinds of things. So what comes with these kits are the brackets that are needed to like hold the switch place. What's really cool about that switch plate is you can flip it upside down and do all the wiring upside down, then flip it back over and hook it up. So all that stuff is kind of called out. So when you get a sensor kit, for instance, you get an ultrasonic sensor, you get a capacitive and inductive, you get the magnet sensor. There's a couple other things you get, and then you also get all the brackets to tie everything together, and then curriculum. So
are the data sheets coming with that, or is there link to data sheets?
I usually include the data sheets. I'm going to open up one of my this one for some reason.
I mean, I'm really kind of more interested, and I mean I can hide the data sheets for my kids, but
yeah,
what I'm interested in is when we did the thing, Maryland, at Jacksonville State College, or Florida State College, Jacksonville, when we did that training, they were handing us the sensor in the bag, and the bag had on it, information. I've got all that documented and pictured so that as I hand a kid a sensor, I can say, first thing you need to do is identify the sensor. And we had a lot of fun with the PNP NPN problem up there because we were wiring and things weren't working. Turns out we had the other sensor,
right?
The PNP versus the NPN, and that is a lesson that has stuck with me because we went down the rabbit hole and couldn't figure it out. And then Tim, who was the instructor, came back the next day and he had figured it out. And he goes, "We have the wrong sensor." And so instead of powering it, we took power away from it, and it worked fine. But it was really big message.
And where we see that is in the PLC class when we hook up the fiber sensor, because if it's not a PNP and if you're syncing or sourcing current right with your input card, it won't work. And because it's like a battery with two positive terminals on it, it just won't work. So you see what I have here. This is what I load into D2L when we do our studies. So right here, it says iReal Cube. So here it is. And here's all the information you need. So I have data sheets for everything that we call out, and I will update. Well, the reason you don't have it is because I didn't give you the whole. Let me just show you. Let me back up here.
Well, that would be good in the Dropbox too.
Yeah, it's because you don't have this folder called Relays Part 1.
Right. I got the lab.
Yeah.
Oh, no, I don't have the lab. I have Relays Part 2.
Yeah, so here's the quiz, here's a video, here's the data sheet, here's some other videos, here's the homework, here's the lab Part 1, Part 2. So when I get that all my silly numbers, all fixed, you'll get all of these full blown, and it's going to look something like this.
All right.
So you've got safety, conductors, DMN, you've got the build. There's the build with all those things we already put in. There's scientific notation, Ohm's law, voltage, on and on and on.
That's great.
Yeah. And I do owe that to Maryland. And the reason it's taken me a while is because it's still kind of written for iMech 2 with that big stainless steel. And I want to get the pictures updated. So I'm kind of changing that. Plus, I've learned a few things about how I explain things that I want to make improvements on. So anyway, so yeah, so this is good feedback, Todd. I really appreciate it. I think you probably speak for the group. Other than I just don't know if people want this thing to be out of the box, every terminal block. Because I was looking at some of that, in the
Well,
prior.
Doug, you're probably about the same age as me. You probably remember the Radio Shack, the book that was yay thick, and you hooked everything up exactly as it said, and then you plugged in the batteries and it worked, and you're like, hey, and if it didn't work, you're like, okay, let's go back through the book. I like that approach, but one of the things I found in doing some of that with my students is they don't learn anything.
Yeah.
They're focused on the objective of getting it to make the sound or read the water level or do the crazy buzzing and stuff, but they don't understand what they've hooked up. They see the diagram, and when you start asking them questions, why is this resistor here, they can't answer it.
Yeah. And I feel the same way, and I'm not going to, because we're being recorded here, so I'm not going to mention any companies, but when you buy one of those Pelican suitcase company trainers and they have a yellow banana jack that goes into a yellow socket, and it's like, well, unless I'm colorblind, I can figure this out without even thinking,
Yeah.
And then there's a picture of the coil, it's like, no, if you want to see a picture of the coil, go to the data sheet.
So I was successful with a little lab last year where I had 5 of my brighter kids. I had a standard 110 volt lamp, and I had a relay, and I had one of the trainers that we've had, and I told them this button here has to turn the light on. That's it.
Yeah.
And I just had to turn the light on. But you had to go through relay. We explained all that, and I gave them diagrams for everything. And it took them a while. They were like, I said, you're not allowed to plug the lamp in until I've checked and made sure you're ready.
Right.
And one of the things that one of the students had done was they had reversed the contacts on the relay. But I said, well, which one's hot?
Yeah.
And he was like, well, this one. I said, no, that one's the neutral. You're going to mess this up pretty good.
Yeah.
And he figured it out. And so we flipped it. And then I said, okay, plug in the lamp. And they pressed a button, lamp came on. Then he let go of the button. He says, oh, it broke. I said, no, you stopped pressing the button. And that kid went, well, I know how to fix that. And so he went over to the selector switch, rewired it, and boom, he had that thing working, turned it on, turned it off. And that's not something I was hoping to get to, but he figured it out that quickly. Because, they don't realize the button is just to make contact, and it doesn't keep contact. But he figured out I needed to keep contact, and that button wasn't going to do it, and I needed to switch. Yeah. So that's was the ultimate plan, but he got there faster. So
perfect. Well, and that's in the labs, mostly electricity labs and PLC labs, where there's a moment where it's got to be right. We always say, stop, ask, go get your instructor. And the instructor puts their initials on it if it's a paper copy. But it stops the student, or even checking with a lab partner before I apply power, because we've had some devastating things happen, in the classroom where people have fried a frequency drive because they hooked up high voltage to the low voltage side. And it was like, if you would have just asked, somebody would have came over and put the safety glasses on and did a run through with you. But here's the document, from the other, and it's just to me, it's too much. And it was a lot of work, and it worked for that particular trainer, but I like the open-ended, hey kids, use your imagination. Like I say, the front end of it, like right here, stays intact.
Yeah.
All this other stuff, and these are kind of in that VGA, 15-pin breakout, but everything else is on the student to figure out. So,
but Doug, going back to that diagram, that is how, if you are setting up a piece of equipment in a factory, that's what they're working from.
Right.
That's what the other guys at Central Community College they pointed that out, was that,
And that's a valid point. It's a very valid point.
so it's useful in both ways, you know, but I also want to turn out kids that can think, you know, because there's an engineer somewhere in an office that says this is how we set the equipment up.
Yeah.
And they get there and something's not right, and it's because the engineer missed something and the diagram doesn't have it, and you know they got to troubleshoot, you know, what's going on. And instead of that 2 week delay going back and forth, maybe they can fix it on site and then just edit what's been done. Like,
Right.
this is what we did. We went over here and did that, and they can send that back to the engineer, and he goes, "Oh yeah, I missed that part. Sorry about that."
Yeah, and don't get me wrong, I do have in the build, they have to follow, like on that switch plate.
Oh yeah, yeah,
If you get that wrong, because all those pins have to be exact. So when you plug the cable in, you're going from that breakout over to the PLC. That's all called out. So
yeah.
that is all
Oh, and
called out. So
yeah, because then you have that little bridge device where you plug into, and
yeah,
then, you know, going from blue to red, the grays have got to link into that zip board or whatever they call it.
yeah, and those have dedicated outputs that go right into the PLC when that time comes. So, you know, there is a lot of this going on. It's still in the trainer that you have in front of you. It's just when it comes to doing like an add-on thing, like they want to build a voltage divider and they want to, you know, run that motor with a voltage divider. There's no terminal block that says how to do that. You just do it on your own in that far, maybe bottom quadrant of the machine, you know. So
Yeah.
yeah.
Well, we use, so down here in this diagram, you've got potentiometer. We actually use a potentiometer in our throttle control of our electric race cars. And I was quizzing my kids, like, you know, why don't we hook up 3 wires? And they were
Yeah.
like dumbfounded. And I said, well, I'll tell you what, why don't you take this ohm meter and you just hook up and find out which side is a 10K and which side's 5K.
Right.
And they came in and said, well, it's 0K and 10K, Mr. Thuman. I'm like, okay. So, but wait a second, when you turn that knob, what happens? Well, then it's 0K, 10K. I said,
Yeah.
so why don't we hook up 3 wires? Oh, we're only interested in going from high to low or low to high.
Yeah.
I said, exactly.
That's
We're
why
not interested.
That's why I included this little potentiometer, and a teacher can say, okay, I'm taking the motor control off and I'm going to build a voltage divider or a rheostat with and you guys can wire it in. It's not a part of the panel. You can just put it on the DIN rail plate and you can put it aside in a drawer and say, well, you know, so anyway.
Oh, cool.
Okay. Well, I tell you, I appreciate the feedback, and I will make sure that I can, because I still have, you know, from what we talked about in Florida, some of the things that weren't quite right, you know, that you guys said, hey, this doesn't, I got notes all over the place, you know, that this is upside down or this doesn't make sense. So I've already fixed that. So, and I'll get new stuff in the Dropbox. But what you'll start seeing, I'll work it through Maryland, is you'll start seeing electricity modules show up. Like the first one might be safety, and that'll be a complete one with homework, quiz, lab.
Good.
And it'll have also a study guide. So everything has a study guide, a quiz, a lab, and homework. Everything has that in each one of those modules. And there might be multiple labs, but at least at a minimum, there's homework and a quiz. So
yeah, I'm hoping that Polk State College adopts this as well, because we're developing a pathway. I'm going to be teaching them CAD skills and then supervising their laboratory work, you know, their exploration of the electronics and stuff. But then, you know, the issue we've always had with Polk State College is, oh, they'll just drive out to us. Well, it's we got a reading recently. We did a survey. Only about 28% of our students have a vehicle or drive.
Yeah.
And, you know, they want them to drive, I don't know, 7 miles from here to the thing to take their lab. And then they say, oh, well, okay, then just get a bus. I'm like, you cannot have a bus from 1 to 2 o'clock, because those buses are in the process of getting set up to start taking kids home. So
And
it's just a logistics nightmare. And
yeah,
if I can do a lot of stuff, then I'd be happy to pile them in my truck at 2 o'clock and we'll drive down there.
yeah,
They can finish the harder stuff that would, too expensive for us to do it here. I mean, they've got wave generators and all that kind of stuff. And I don't know if I want to put all my money into it, but the basic electronics, the basic
yeah,
understanding of wiring up the circuit, and then, have them do some crazy stuff that, experiment around, and then videotape that, take pictures, diagram what they've done, and then maybe
yep.
submit that as projects and things.
That's
So,
exactly what we did during COVID. I mean, I mean, I was doing these for IMEC for the National Science Foundation, but if you saw the classroom I taught out of, the walls are wallpaper. They're adorned with trainers, different types of trainers, freak drive, sensor trainers, electricity trainers, PLC trainers of all different PLCs. And I put them in the back of my pickup truck, and NSF did an article on it. And kids were coming up to the back of my truck, taking the trainer home, and I would hold a lecture once a week. And if they wanted to join in, fine. But I would have them show me on their screen, their camera, that they were actually understanding or doing a particular lab. So it does work in that rural sense. I mean, you can send these things out, and because now we've changed over to 24 volts DC, there's no more high voltage. They're very safe. There's really no pinch points on it. So it is a proven way of doing it, and the cost isn't like and again, I won't mention any commercial people, but it's not like a $15,000 trainer that you're going like this, like, please, oh please, oh please, don't leave this in your trunk over the winter.
mm.
So
But again, Doug, going back to the Radio Shack thing, the key element, I think, to what you're offering is the curriculum.
yeah,
I've been through some trainings, the low cost trainers and that kind of stuff, but really the essential difference between like an Amatrol piece of equipment or some of the other companies that, $10,000-$15,000 for stuff, the end goal is they've got a ton of curriculum, they've got opportunities. Of course, businesses are designing this with Amatrol, and that's what they're putting out. But the low cost trainers are infinitely more. You can get those in the hands of so many more people,
yeah,
especially when your trainer is $1,000 and I can put 15 out there for 15 grand. That's a whole
yeah,
different, it gets
yeah,
more people playing with it, figuring out they like it, and want to do more with it because there's a curriculum that builds towards. I mean,
yeah,
I can teach electronics, but what are we doing? We've got a little resistor and a little LED, and we're plugging it to a 9-volt battery, and then we're changing things up. And we're blowing the LED, and oh, that's fun, isn't it? Or the capacitor blew up on us. But ultimately, going to the practical nature of having a garage door roll up, and some way when it's coming down, you can stop it because you've built in all the sensors, you've figured out why that works, and you've done it by critically thinking through the process instead
yeah.
of having a step by step, add this, add that, add this,
Right.
wire this to this, and boom, press go.
Yeah, some of the best things is, I mean, where you say to these kids, design a car wash, and you do it right on here. Each light is a process, and but you don't give it to them. You don't give them the code. You say just do it, and get the data sheets and make sure that you're going to open up a big door that that
Yeah,
your PLC is not going to blow up because you're driving a big freak driver of an AC motor. And these kids, they just, I don't know, they just embrace it. And some of the kids that you wouldn't think would do it are challenged, going, well, I've been in a car, a car wash. How does that work? Let me think this through. And voila, they have one built, and it's like, you know what? You just designed a little car wash on your little trainer here.
yeah.
So,
And that I think this board's going to support all that, and I especially looking forward to the evolution as you.
well, I'm
Well,
excited at high tech. I've got a little HMI that has a little arm that sits off to the side. I'm gonna have all the sensors going. I'm excited about really unveiling.
what's high tech?
It's a conference. This year it's in Austin, Texas. But I mean, I have most of the stuff ready right now, but I also want to get possibly the process control trainer redesigned and take weight and cost out of that as well. So,
Oh, that's in June?
yep, July.
June 20. I'm looking at HITEC.
It's in
Is it in
July.
Austin?
It's in July.
It's in July. There's
I'm
another
looking at the
healthcare
wrong
one
one.
that's kind of confusing.
This one says San Antonio, Texas.
That's a different one.
All right.
You can send them the link, Doug.
Yeah, I'll send you the link.
Yeah.
Please do. I'd be interested. If it's in July, I can probably make that, see if I can use
It's
some
usually the
cable.
last, it's like the last week or the second to last week typically.
Right.
Well,
Yeah.
Joy, just
Yeah.
before school starts.
Yeah, right,
Yeah.
exactly.
Yeah, exactly. Well, okay. Well, Todd, I appreciate this, and Marilyn.
Well,
And
Doug, I feel like I got a solo presentation here. This is
well, and again,
Yeah,
Marilyn,
personal session.
one-on-one training. That's how do I pay for this in the future?
you're gonna next time when there's two people, you're gonna feel like, now wait a minute.
Will he
And
stop talking?
Yeah, I just wanted to kind of go over kind of, the way how the trainer can be used, and, with those experiments, and now that you have um, the all the drawing that you can wire in, that
Well,
motor
that's what I'm
control.
taking with me to Athens. We're gonna
Yeah,
get that puppy running.
it'll be fun. And then and everything on how to put that motor, that sprocket together, how to lay things down and start the screws, and it's all in there because everything has to kind of happen in that sequence. But I captured it all in the drawing. So, and never, please don't miss the opportunity to circle, check, send things back to me saying, hey, typo here, Doug, or you can do a
Okay.
better job explaining this, or this is out of sequence. You're assuming the audience knows this. Let me know, because anything that we can do to improve it makes it better for everybody else.
Will do.
Okay.
Thank you, Teresa. Thank you,
Right.
Marilyn.
Yeah. Thank you,
Well,
Teresa and Marilyn.
thanks for showing up.